So we're having an example one. They're saying in 2000, a population of a small town was 1.2 million. Then 1.1, they're saying find a formula for the population P is equals to f of t with t in years since 2000. So since this one, it means here they're basically telling you your reference year. And you remember when I said if you're doing this type of examples, always consider the last two digits in your years. Like you see with this one, they were referring to something like your 2016. So what they had to do, they just like took the last two digits and just told you to work it out. So for you, it means now your t of 0, your t is equals to, why is it doing this? Let me try right on this side. No man. It means now your t is equals to 0 because they said your reference was your 2000. Or is it because I'm writing on top of these pages? Let's try writing this side. They said that's okay. Okay, let's try it again. I'm just gonna write big things, then it doesn't matter. Seems like when I'm adjusting it to bigger things is better than big things it is, because it's like it's acting up now. Then yeah, it means now your t of 0 would be your t of 0 would be your reference here. Then let's just check again what they're saying. Then they're saying t in years since 2000 and p in millions if the population is growing by 750 per year. So this 750 per year that you see, it's your rate. And you remember your rate, this is the same as them giving you your remember the formula. You have your y equals to your mx plus BUC. Let me try this other stylus, this one. Okay, this one is better. We have y is equals to mx plus b. Then they'd say to you the population is growing by 750 people per year. This will be the same as them giving you your m. Then we have to check the units that like are given. Then they're saying the units, the population is given in million, so it means now you have to come again and divide this one by your million. By your million, so what are you going to get? You're going to get your 0.000075, and this will be equals to your m. I thought this one was better. Okay, but like hopefully you're able to see the things I'm doing. That would be your M. What else is given? They've given you the T of 0, which is your reference here. Actually, these ones are supposed to be the ones that like give us our point. Remember, when you're going to draw a graph, if you're given a question that like you're supposed to draw your graph, you go and check that, okay, you have your graph which is like this. Then you check that, okay, if you're going to have a graph like this between your population and time, which one is going to be dependent and which one is going to be independent. You will see that on your x-axis, this is where we have the we have your x and y. This is where we're going to have the one which is your time. Then this side we're going to have your population. So your time, it's independent, then your population, it's dependent on time. So you know, on your y-axis you're going to put the one that's dependent, then on your x you're going to put the one that's your independent. And you know, if you were required to find the slope, your m, you know you're going to have your delta p over your delta t. This is the same as having your delta y over delta x, because like I've seen also sometimes students also mix those ones, whereas you get them writing your time then at the top and your population at the bottom. So you just have to remember that one. So now they've given us 1 point. They've given us what did they give us? They give us our T of 0, which is the reference here, and also this 1.2 that you see this side. So it means remember this one at the top, we have y over x, and if we have a point, we're supposed to have an x and y, you see. So it now means our x is going to be a 0, which is that reference here. Then our y this side is going to be 1.2. So I said we're going to have what? We're going to have y is equals to your 0.00075 t plus b. Okay, at least now it's back again, it's working better. Then now we set the point that we have at 0 and 1.2 million, which are given the top. We have that 0 and we have that 1.2. Then as we know, this is your x, this is your y. Then we'll say we have our 1.2 is equals to 0.00075 into 0 plus your b. So this means now your b will be equals to your 1.2. So your final equation, you will see that you have your 0.00075 t plus your 1.2. See? Then were you required to find the function, or are we actually doing the lot? Okay, yeah, I think we're still on the right track. And now they're saying the other ones are just like straightforward. Find your f of 16, and yeah, basically they just want you to find the population in 2016. They give you your f of 16 and your derivative of that. Then you see for your first one, okay, if you're going to get the derivative, Now let's just do them separately. The first one, they wanted you to find your f of 16 and the derivative of that. So if we input 16 this side, you will say you have your f of 16. You have your f of 16. I don't like this stylus because it makes noise. Then we have 75 into 16 plus your 1.2. What are you getting? Can someone just confirm that one for us? Anyone, please confirm the answer for us. Yes,
the answer is 1,212.
1,212. 1,212. This is millions. Then now we're going to consider the derivative of 16. Then we go and check that, okay, we have our function. Where is our function? Our function is here. So first, if you look at this one, what do we have? Let me just write it again. We have y is equals to 0.00075 t plus your 1.2. If we find the derivative of that, you will see that like we'll only be left with y is equals to 0.0075. See? So now you will just say from 2006 to 2007, 2016 to 2017 the population increases by 750. Remember, this is the population already in millions. You basically have to just like multiply this by your millions to go back to your 750. So you will conclude and say from 2016 to 2017, what happens? The population increases by 750. You see, so each and every time you are asked to find something like a derivative, you always reference according to the previous year, the recent year that you are given and the upcoming year. You see here we were given 2016, but in my conclusion I was referencing also to 2017. So that's how you go about answering the question. Then let's see. Okay, you have example 2. Okay, since we've done one example this one I'll just quickly write. We have 2.1. Find a formula for the population p is equals to with t in years since 2000 and p in millions if the population is growing by 7.5%. 2.2, they're saying find if the population is growing by 7.5%. 2.2, find your G16. Yeah, let me just quickly write the answers for that one. so that like we can also do the other example. So we've already wasted 15 minutes on that one. I'll just quickly write the answers for that one. Then if you're still struggling with that, we'll discuss it. We have p is equals to f of t. What do they have there? 1.2000 population of small town was 1.5 the population. No man, yeah, it's much of the population since 2000 and p in millions. The population is growing by. Okay, now we are using exponential function. So let me just quickly write the answers. We're gonna have 1.1. Then this side, I'm gonna have this. Then we're supposed to find. Oh yeah, let me just start with your g of 16. Then you will find your g of 16. Then the other one you do your derivative. So as long as like I've written the first one, then the other ones you'll just like finish them on your own. Then let's move to example 3. Example 3 they're saying aspirin decays at a rate of 20% per hour. So they say how much aspirin remains in your blood after 1 day after taking 500 milligram of aspirin, you see. So now you also have to consider this part where they're just like explaining your decays and your rate. So in this example, what do you have? You know that we always have our A would be equals to our 1 plus our R. But now they're saying aspirin will decay at a rate of 20%. So now it means our new A that we're going to be having, we're going to have 1 minus the 0.2. So the 0.2 is just like that 20% divided by 100. Going to get that 0.2. So since it's decaying, that's why I'm subtracting from 1. So you're going to be left with your 0.8 or your 80%. Since you're left with your 0.8, then now you have to write the formula and try to substitute the values. So now we are working with what? We are working with quantities. You have Q with such that you have your initial quantity, then you have your A to the exponent T. Then now what did we work out? We've already worked out our A. We said our A is going to be 80%, which is your 0.8. Let me just change it back again, which is going to be the 0.8. So now that you know that one, what's the initial? This one, remember, this is your initial, or you can say it's your initial amount. You go and check. They're saying okay, let's just reread it again. Aspirin decays at a rate of 20% per hour. You see, in this example, you're going to be working in hours. How much aspirin remains in your body after 1 day? What's 1 day in terms of hours? 1 day in terms of hours, it will now bring us to 24. So now we already know that, okay, our T is going to be 24 hours. Then our initial quantity, it's given that side, it will be that 500. So now it means we have 500. No, man, stop this. We have 500 into our 0.8 to the exponent 24. Then can someone please calculate that for us?
It is 2.36 milligrams.
That's 2.36. So you will write you have 2.36. So basically this now means you're gonna go and make a conclusion that okay, it means after 1 day only 2.36 milligram will remain in the, is it the blood? The blood system. Let me check. Oh yeah, as that. So the only thing that like you had to know this side is someone requesting to be in. Sorry. Okay, yeah. The only thing that you had to note or change is your 1 day and convert it to your hours. It's your 1 day, and also the key weight decays. So it just tells you that it decays at 20%. Then you know you're going to have that 1 minus that 0.2. Then you're only left with your 80%. Then after 80%, you just calculate because now you're given your initial quantity this side. Then after that, you do your conclusion. Then now we have another similar example. Then now they're saying if a quantity decreases at a rate of 10%, we're still having an example where we're supposed to use a decay. So we still have around a is equals to 1 plus r, but now we're dealing with a decay. We're going to say, what do we have? We have 1 minus the 10%, which is your 0.1. It means now you're left with your 0.9, which is your 90%. Then now, okay, let me just do this because now we are here. So you see here, what are we dealing with? We are dealing with hours, and this side they're saying we have 3 hours. So it means now we don't have to do any conversions. So we just have to check the percentage. So let's quickly write this. Remember, we're dealing with quantities, hence that's why you see me using Q. So what are you going to say we have? We will say we have our Q is equals to our Q0, then we have a to the exponent t. Then now in this question, they didn't give us the Q0. So you just say you have your Q is equals to your Q0, which is your initial quantity. But now you know your A, it's your 0.9. 0.9, your T, it's 3. So now what do you have? You have your Q is equals to QO. Then what's your 0.9 to the exponent 3? Let's do it fast, guys. Let's do it fast.
The answer is 0.729.
So now you're going to have your 0.729.
729.
Yeah. So now it means you're going to be interpreting this answer in terms of multiples of initial quantity. So it means now that, like, okay, the multiple that's going to remain after 3 hours, it's going to be your 0.729, which is basically this multiple, which is basically your 72.9%. See, this is the only amount that's going to be in the bloodstream after your after your 3 hours. So that's the conclusion that you're going to make. You will say something like the multiple of your initial quantity or your QO that remains after 3 hours is 0.729, or you can say it's 72.9 or 73%. That is also acceptable. Then what do you have? So now we'll just be moving straight into your financial maths, the compound interest in the number or base E. Okay, they say suppose BO is the rent deposited into an account and the interest that is compounded n times. Basically, your n is the number of times, then your t is the number of years, or your BO you can say is your initial quantity. Then now they just straight up ask you the questions that, okay, what would be the amount in your annually, compounded, monthly, daily. So annually, annually it's 1. Then monthly, you have 12 months. Then we have daily and we have quarterly. If they use quarterly, just know it's 4. Then daily we use 365. I think someone was also writing them this side. You can see the only one, I'm not sure if like this example it has a quarterly example, but like, yeah, just know that quarterly you're going to use your n as 4. So they say you deposit 1,000 into an account with interest.
So can I ask?
Yeah.
For quarterly, isn't it 3?
Quarter. I don't know. We have 4 quarters.
Oh, yeah. Okay.
Yeah, because like if I still remember, it's annually, monthly, daily, quarterly. Do we have any other ones? No, I'm not. No. Oh yeah. Or maybe I'll just like think about it. But yeah, those are the only ones that like they're going to ask you about. Then they say you deposit 10,000 into an account with an interest compounded at an annual interest rate of 6%. Then what is the balance in the account after 5 years? So now it means we're basically still going to be using this formula, but now the only difference that we're going to have, we're going to be multiplying. Where you see your n, for the first one we're going to use 1, the second one we're going to use 12, then the third one we're going to use 365. So let me just like also write them quickly. Okay, we have the first one. Okay, we have B is equals to BO. What do we have? We have BO into your 1 plus R over N. This is the same as, let me see. Okay, so your 6% is going to be divided by 1, so there's no need to write the thing. But like, yeah, let me just write the formula here. 1 plus r over n into 1 plus r over n. Then this side we have nt. You see? So in all these other examples that you see, I think this one you can also attempt it, since it's quite straightforward. So what you're basically going to be doing, where you see your n, you put your 1 on this one. Where you see your n, you put your 12. Then the other one is 365. Then you just like punch that on your calculator. Your t, it won't change, it's just going to be 5 throughout. Then yeah, so that like we don't waste time on the stuff. That's straightforward. Then let's just check another examples on unit 3. Okay, after this one let me just remove it because we're done with it. Let me just do this and see if we don't have anything underneath. If we even have something, I was just gonna remove everything. Okay, we have that. Let me check from the book if we're still following the order. Okay, we did this one, This one we're supposed to do. Is it the one, this one at the back? Oh yeah, that's this one. Let me enlarge this one now. Let me enlarge this one. So now we're getting to the second part where we're going to be using base E. So they're saying we have some definition that you have to read this side, but normally with these ones, if and only if you get an example where they tell you or you see where it's like you compounded continuously, just know that now you're going to be using what's this thing, your base E, you see. So just keep it in mind that like each and every time I'm having something like your base, your compounded continuously, it means I'm going to be using base E. So literally you're using this equation that is given this side, which says your b is equals to your b0, your e to the exponent r of t. Then what do they say? They say, example 2, what is the balance in the account after 5 years if you deposit 10,000 at an annual rate of 6% compounded continuously? This is exactly what I was referring to. So now you have a situation where you have your 10,000 in your account. Then you will say you have your b is equals to your b0. Then you have your e to the exponent r of t. Then they said you had deposited your 10,000. Then you have your e. Then the interest. What's the interest that you have there? You have your 6%. Your 6%, then it's after 5 years. Then it means 6 is your 0.06 by your 5. Then can you quickly give us the answer for that one? Anyone?
The answer is 13,198.
It's 13,198.
198.
Okay.
588.
Okay, let's just say 59. Then that's that. Then let's go and check. We have another example this side. What are they saying? Okay, this one is already calculated. We're gonna go and check example 3. Example 3, they're saying if an annual interest rate of 4.5% is compounded continuously, find the effective annual interest rate. So they're still using those words, compounded continuously. So it means we have to use that formula where we have our base of E. Let me just check the values. They're saying we have 4.5% is compounded continuously. Find the effective annual interest rate. Annual means now we're going to have our n is equals to t actually. So now we're going to have that formula again, that we have our b is equals to our b0, we have our e to the exponent rt. Then they didn't give us our b0. Then we have the b0, we have e, the percentage they gave us 4.5%, that's like 0.045. Then our t is 1. Then now we have b of 0. Then what's the answer for this one?
The answer is 1,046.
And the answer is?
Hello?
It's
1,046.
1,046. Yeah. Then
should I call out all the decimals?
Nah, it's fine like this. 3 is just fine. Then what exactly? Oh, they wanted the percentage. So now you're gonna say you have your 0.046 by your 100. Then you give out the percentage. I think it's like your 4.6%. And with this one, the final answer, you will write you have your 4.6%. So you will say the effective interest rate is your 4.6%. percent. You see. So let's go and check the other one. Let's check. We did example 3. Then after example 3, there has to be example 4 somewhere. Not the other one. Example 4. Let me check from this book. Why is it from 3.4? Okay, never mind that. I think now what we were supposed to be doing, it's your oh yeah, we can do the what's this thing, the properties. We can do the properties. After doing the properties, we'll see the other examples. Maybe I'll just because this one's, I feel like I should have maybe created or scanned this thing so that we could have a nice working order. But I'll make sure we don't miss anything. So let's just do the properties, explain the properties for base E, because these are mainly the ones that you're going to get. So make sure that you don't miss this. So the properties for base E, what's the first one? Okay, the first one, and let's just say you have something where they've given you your e to the exponent x multiplied by your e to the exponent y. Then you know this is the same as having e to the exponent x plus y. The second one, what do we have? We can say we have your e to the exponent x over your e to the exponent y. This is the same as having your e to the exponent x minus y. This thing has started again now. Let me change the stylus. Okay, x minus 1 minus y, I want to say. Let me erase this one this side. Then what do we have? We can say on the third case, we can have your e to the exponent x. Then we can have everything to the exponent y. This is the same as having e to the exponent x y. Okay, then there are ones that you need to know the properties from your logs or your logarithmic. Then okay, I'm just gonna write a. Then let's just say you are given something like your ln of a. So if you're given something like your ln of ab, this you can break it down in the form that you have your ln of a plus your ln of b. You see? Then the second one, okay, I just remember them from the example. You have your ln of a over b, so I just hope you're also writing them down on your side. Then you can have your ln of a minus ln of b. Then the third one, which is the most popular one, they just like this type of examples because like I don't know, it's like maybe most students just like miss it out. You have regular ln of a to the exponent c. This is the one where you are allowed to bring the c down. You can have your c ln of a. Then I think that's all. So these are the ones that you're going to have 1, 2, unless if I'm missing any, but other than that, the other ones we're just gonna remember them when we're just busy with the examples. So I'm just gonna do some few examples with you guys. Okay, let's just say now we have an example where they say you have to find u if you were given your e to the exponent 3x multiplied by e to the exponent 7x all over your e to the exponent 4. Then this side is multiplied by your 2x. That's equals to your e to the exponent u. You see? So you try and use the rules that like you learned. So these ones at the top, you can add them together. So what are you going to have? You're going to have your e to the exponent 10x. Then same thing with these ones at the bottom you have to multiply. Then you're going to have your e to the exponent 8x. Then from here you're going to use which rule. You know that you're going to use, I thought I had written it down. So this is the same as having your e to the exponent 10x minus your 8x, which means now you're going to be left with your e to the exponent 2x, you see. But now, what were you given on your right hand side? On your right hand side, you were given e to the exponent u, but now you've only managed to solve your right hand side. You said you got your e to the exponent 2x, which is equals to your e to the exponent u. Then you have base of e, then it means those ones you can equate them. And now it means your u would be equals to your 2x. As simple as that. You just have to remember a mixture of these rules when you are busy solving these examples, but like the more you do them, the easier it gets. But like I think for you guys, you should be able to remember some from your grade 11 and grade 12. If you still don't, doesn't matter. You can just like remember from the ones that you're gonna be given in WTW. And let's do another one. So another one, they say find v if you have your 2 ln of x minus ln of x cubed is equals to your ln of v. Okay. So now you have to disregard the other part for now, this one in yellow, and focus on the one on the left hand side. You see? And with this one, let's check, is there something that we can do? Okay, are you guys able to see that this one, they've used that rule where I said like they like to use it in most of the the questions. That's basically this rule that you see this side. This is where the 2 was, where it was the c, then they've replaced this side. So it means we can reverse this thing actually and say we have our ln of what? Our ln of x squared minus ln of x cubed. Then if we have a ln of x squared minus ln of 3, which rule are we now going to be using? It means now we're going to be using rule number B. It means now we can say we have ln of x squared over x 3. So this is the same as having your x to the exponent 2 minus your 3. Then you know this is going to be your x to the exponent minus 1, which can be written as 1 over x. So it now means you're going to have ln of 1 over x. You see? So you have your ln of x as your final answer, but that side you have ln of v. So it means that side you have, what do you have? I think I've highlighted in yellow. Then this side you have your ln of v. So now it means your v would be equals to your 1 over x. You see? So yeah, it can be quite tricky and confusing, but like you just have to check carefully if you can't twist these things around. At most you'll be required to use like a 2 to 3 properties, sometimes a combination. You see, sometimes I'm using 1 in the logarithmic, the other time I'm just going to be using 1 this side and mixing it with the other 1 in that portion. So do I have okay, the other ones, these are just the ones where they just say you solve and give the exact solution. So let's just say you are given a question where they just say solve and give exact solution. So they've given you a statement like this. Then the first example that they say you have e to the exponent minus 2x is equals to 8. Then you know that okay, each and every time you have something like your ln, because like basically now we're just trying to solve for x. So how it works is that like if you are given e and you want to get rid of e, you introduce your ln. And if you have your ln, you want to get rid of ln, you introduce your e. So these are just like working vice versa. So now you see we have a situation where we have e. So in order for us to remove the e, it means we must introduce the ln. So we're going to say we have ln of e to the exponent minus 2x. This is the same as having a ln of 8, you see. So now we're going to be having minus 2x, which you can bring it down. Then we can have ln of e is equals to ln of 8. Then this one, you know, your ln of e, that's 1. So it now means you have what? You have your minus 2x is equals to your ln of 8. Then from this one, you can just divide by your minus 2, divide by your minus 2, then your x would be equals to your ln of 8 over that minus 2. Then you're done with that one. Then okay, I want to give an example where now they are using your ln. So let's just say now you're given an example where you have your ln of x is equals to minus 8. And remember, as I said, if you have ln, you introduce e to get rid of the ln, and if you have the other one, basically, yeah, like that. So now I'm going to introduce e. You will see that now I have what? I have e to the exponent ln of x is equals to my e to the exponent minus 8. You see? So from this one, you know, this one you'll just be left with your x. Then this side you're going to have your e to the exponent minus 8, because your e to the exponent ln of x, this one, it would, yeah, it still gives you something like your 1. So that's why. And remember, this one you can bring it to this side, which is basically what I did here. You're actually supposed to write your 1, but like I just like wrote the final answer. Then okay, I think I've highlighted the one for ln. And do we have any other tricky example we can use? Let me just check. Okay, so yeah, I think I've seen one example. This side, what do they have? They have ln of 2x as equals to 4 minus your ln of x. So if you have something like this, first try to rearrange and see if you are not getting anything, because already I can see I'm having a negative to that side, but when I'm taking to that side, I'm gonna have a positive. It means already I'm looking at this two, like they all have their length. So let's just check. If we were to rearrange, we're gonna get something like ln of 2x plus our ln of x is equals to 4. What are you able to see? You can see that, okay, from theory, what did I say from theory? From theory, you know that your ln of a plus your ln of b, this is the same as ln of a by b. I just hope I wrote it down. A by b. Oh yeah, as this one that you see this side. See? So going down. So now you already know that, okay, you have something like this, and it means now you're going to be multiplying your 2x and your x. So what are you going to have? It means now from this theory that you have here, you're going to have your ln of 2x squared, which will be equals to 4. You see? Then when you're at this side, you see there's actually nothing more that you can do. What you have to do is to introduce your e to get rid of your ln. So now you introduce your e, that you have your e exponent ln of 2x squared. 2x squared is equals to your e to the exponent 4. You see, sorry about that. Then you know you are allowed to bring that one down and be left with your e to the exponent ln on the top. So it just means you can write, you have your 2x to the exponent 2 is equals to your e to the exponent 4. So now you know this one you can divide by 2. You can divide by 2. You're left with x is plus or minus the square root of e to the exponent 4 over 2. So yeah, that will be the final answer for that one. Then okay, another one that's a little bit similar. Okay, we're done with that one. Another one that's a little bit similar but different. We have ln of x squared is equals to your ln of x to the exponent 4. You see, so with this one, the rearranging, if you try to rearrange, you will see it's not actually going to work for you. So but like, can we introduce base of e? Surely yeah, we can. Then if we introduce base of e, what are we going to be left with? You see that on the other side we're going to be left with x squared, then on the other side we're going to be left with x to the exponent 4. So are those ones factorable? Yes, you know you can take your x squared out from your x to the exponent 4, then you're left with your x squared minus 1. You see? So yeah, it's just a matter of practicing a lot. You're actually supposed to solve this thing in your head before you can quickly go and write it down. So you're going to have what? You're going to have your e exponent ln of x squared is equals to your e exponent ln of x squared. So x explained in the previous, you know, you'll be left with your x squared, and this side you have your x to the exponent 4. Then if you take this one to the other side, it now means you have your x to the exponent 4 minus your x squared, which will be equals to 0. Then you know you can take your x squared as a common factor, then you're left with your x squared minus 1 is equals to 0. You see? So now what does it mean? It means you have your x squared, then this one it's a difference of 2 squares, then it means you have your x minus 1 into your x plus 1 is equals to 0. Then you know your x will be equals to 0, or x will be equals to plus or minus 1 for these ones that you see on the other side. You see? So that's that on that. Then now I think we have to go to unit 3.4, 3.4, 3.5, 3.6. 3.4. Did I have these things this side? Okay, I'm just checking something here. Because I rearranged my examples, I'm supposed to be having them also that side. Okay, let me do this answer. Um, 3.4. Okay, yeah, I see we have some nice ones this side. I have nice ones this side which we can enjoy. Okay, let me just set up this nonsense this side, and wait, what's happening? Okay, let's just hope I'm able to read. Okay, that's fine then. If it's like that, what matters is for us to see the examples. Okay, so yeah, let's get to work. They say the doubling time of an exponentially increasing quantity is the time required for the quantity to double. English. Okay, relax. They're saying the doubling time of exponentially increasing quantity is the time required for the quantity to double. Okay, so let's just take it slowly. We're dealing with quantities, write whatever we have, and we see where we're going. We have Q, it's equals to your Q0. What do we have? Yeah, we have our E to the exponent K of T. You see? So now we have to check what exactly are they talking about. They're talking about the doubling of our quantity, which means now okay, the doubling of the quantity, which is this one. Our quantity is this one. Then we have our QO this side, which would be our initial. So what is in the doubling time of an exponentially increasing quantity is the time required for the quantity to double. For the quantity to double. So now it means in this instance we're going to have our QOs are just going to be equal, so which means we're going to have what? We're going to have our Q be equals to the QO. So now we can come again and say, what do we have? We have twice times the QO is equals to your QO, then we have E, the exponent KT. So this is basically what they're talking about. Then now from this one you can just like cancel them out, then say you are left with what I didn't check. What do we have on the time? We have 15% per hour, which means it's just going to be your 0.15. No, I was just checking the other one. We have 15% per year. Okay, yeah, we're still on the right track. Then they say find the double and half of a quantity growing at a continuous rate of 15% per year. So it means now we have 2 is equals to E. Then what do we have? We have that is 0.15 T. You see, so now you see we have base of E. So it now means somewhere along we have to come and introduce that lane we were referring to, because like I said, once you see your E, you introduce your linear to get rid of that one. Because now what are we supposed to find actually here? Here it seems like they're interested in the T, which is your time. So they're saying find the doubling time. Find the doubling time. Find the doubling time. Find the doubling time. Hence, we're working to find the T. So it means we're going to be having ln of 2 as equals to your ln of E to the exponent of 0.15 T. So what are we going to have? We're going to be having ln of 2. We're going to have ln of 2. This side, what are we going to have? We're going to have 0.15 T. Then this side we're left with the ln of E, which is going to be 1. You can just cancel it out. Then we are only interested in working out this remaining part. So it means here you can just straight up divide with your 0.15, divide with your 0.15. That means your T would be equals to your ln of 2 divided by 0.15. Then can someone give us an answer for this one?
The answer is 4,62.
Then you have your 4.62. This is given is in hours. Is it in hours? We have to check everything. They didn't even say anything, so you can just write units, 4.62 units, because here they didn't specify. If they didn't specify, you can write in units, then they know it's just going to be applicable to whatever units they are referring to. Then yeah, these ones they can be a little bit tricky. Then they're saying determine the half life of a quantity decreasing at the rate of 15% per hour. You see, so now they're talking about per hour. Oh, that other one, it was per year. Sorry for that. They did mention that it was per year. This one, it's per hour. So that one was per year. So with this one, let's just see. Find the half-life of a quantity that decreases at 15% half-life. Determine the half-life of a quantity decreasing. Use the formula. Yeah, I was just now thinking Q Wait, does A work this side? No, it's supposed to be E. Okay, let me just erase this, then we can. Okay, let's relax and read it again, and just to make sure we're doing the right things. So they're saying we have the half-life of a quantity decreasing at the rate of 15% per hour. Oh, now I get it. The reason why they are telling us exactly that we have to use this equation is that actually this question, if it was me, you can actually do it in two ways. You can use this equation that they've given this side, or you can use the one where you have your Q is equals to your Q0, then you have your e to the exponent kt. You see? So now what are you going to have if it's something like this? Then now you know that, okay, this side, oh yeah, you said you're going to have your Q is equals to your Q0, then you have your E, then they said you're getting a decrease of 0.05%, so 15%, then you're going to have your 0.15, then you minus that, then you bring your T, then from that, the only thing that like we forgot to do is the half-life. That's half-life, that's your 1/2. You come and introduce your 1/2, that okay, you have 1/2. Then this one, as we've said in the past, then they're saying the half-life of current decreases. Then you have half of QO and QO are just going to be equal. This one and this one are just going to be equal. You can just like remove them from the equation. Then you're left with your E to the exponent minus 0.15 to the T. Then let's just quickly write it out. I want to see if maybe they're still going to be the same or what. And this side you're going to have your ln of E minus 0.15 T. Then what do you have? You have a ln of 1/2 is equals to minus 0.15 T. Then you divide by minus 0.15, divide by minus 0.15, then your T, that's how much? A ln of 0.5 divided by minus 0.15.
It's an error.
That's an
It
error?
doesn't show that. Yes.
Is it? You said ln of 0.5 divided by minus 0.15.
Oh,
Ah,
sorry. Oh no, it's 4,62.
Okay. Let's trace. Then you can say it's approximately 4.6. So, 4.62. Then let's just check. This was one other way that like you could have used. The other way, you remember, if we use the method where we have a is equals to 1 plus your r. So now it makes sense that like there we're trying to at least maybe shorten the way, because like others could have went with this way, then the other ones could have used the other method. So they're saying you have to use your q is equals to your q 0, then you have your 8 exponent t. So what do you have? Okay, you're going to have your 1 minus your 0.15. Okay, this is going to be, as it's your 0.85, you get left with your 0.85. So it now means you have your q is equals to your qo into your 0.85 to the exponent t. Then we're just going to introduce 1 over 2. Then those ones, your q0 will be equals to that one. Then we're gonna have a 0.8. Then we have the 0.85 exponent t. Then how do we work it if it's something like this? I'm confused. Seems like this one, it's not gonna work. Because now, even if we introduce lin, you did everything correct, but t, there's no way you can find t in this one. So with this one, this is where as far as you can go. You can't go any.
Sir?
Yeah?
Can you not use a logarithmic function to find t?
What do you mean? The lin?
The log.
The log. Oh, we don't use log in WTW. We use the lin and that one of the base E.
Okay, but it is possible with log.
With log. Yeah, with log. That's why I said like with this one you can't use your lin and E. So with the WTW we don't use logs. So never use logs.
Okay.
Just leave it like this, but if you want to continue it with log, you can. So let's do the other example 3. After 3.4 we have to do 3.5. We still have a lot of work. So the ones that like I would prefer, just use the previous example that like we used. Use the one where your continuous formula, where you have your E in your formula, which is which one? I have written them, which is this one, your B is equals to your B E R T. I'd rather use this one. So let's go to these other ones. Okay, what are they saying now? They're saying the half-life of nicotine is approximately 2 hours if you smoked one cigarette at 7 o'clock. When will the percentage of nicotine in your body be less than 30%? What percentage of the nicotine remains after 12 hours? Okay. Hey, they're looking for this one. Okay, let's just read it again just to make sure. The same. The half-life of nicotine is approximately 2 hours. If you smoked one cigarette at 7 o'clock, when will the percentage of nicotine in your body be less than 30%? So what are we given now? We're only given 2 hours. And we're only given 2 hours and we only know about the half of quantity. So what we don't know, that's our value of K. If we can know K, then we know that am I right? Oh yeah, if we can know K, then it means now we'll be left with that unknown T. Then we'll be able to determine the time. You see? So okay, let's try to break it down slowly. Is that okay? Let me do this. Yo, it's been long since I practiced maths. The only time when I get to practice maths is when I'm doing it with you guys like this. Other than that, I'm always at work. So, but like nothing, it's ever challenging. There's always a solution. So we have Q is equals to Q0. Then we have e to the exponent kt. So now the only thing that we're interested in now is to solve the k. The k would be the one that's gonna help us in determining the t, which is going to be our hours. Then this side, they've told us that okay, we're going to be having our half-life of nicotine. Then we're going to have half of initial quantity. Then this side, as usual, we have the initial quantity. We have our e to the exponent k multiplied by the 2 hours that's given. Let's do this. We have that k multiplied by that 2 hours that's given. Your q0 and q0 will just cancel one another. Then now we're left with 1 over 2 is equals to your e to the exponent 2k. Then now we can introduce ln of 1 over 2. This is the same as having ln of e to the exponent 2k. Then we know ln of 1 over 2 would be equals to our 2k. Then we can divide by 2. Then we divide by 2. Then we'll see that our k would be equals to ln of 1 over 2 divided by 2. See? So far, we've only done like smaller portion of the work. Then now that's when we can start attempting to answer the question. You see? So now they're saying, they are giving us a scenario where they were saying our Q is supposed to be 0.3 of the initial quantity, which is 30% of the initial quantity. According to the statement they've given us, they say, when will the percentage of nicotine in your body be less than that 30%? So now it means you can go again and say, okay, you have your even 0.3 or 30, it's fine. Then this one, you know, they're still going to be equal. Then what do you have? You have your e to the exponent. What's your k? You have your ln of 1 over 2 divided by 2 by t. So this one, let me just do it like this. Then, okay, this one's cancels one another, or just no, it will always be like that. Then what are you left with? You're going to be left with your 0.30 as equals to your e to the exponent ln of 1 over 2 by your t. Okay, yeah, we're getting there. Then we introduce ln. We have ln of 0.30 is equals to your ln of e to the exponent ln of 1 over 2 by t. So what are we going to have? You will see that, okay, your t, because you're going to bring it down. Okay, let me do this. Your t, since you're going to bring it then down this side, it means you can have that ln of 0.3 to this side. Then you divide it by what? By that ln of 1 over 2 divided by 2. Then what will be the answer for that?
The answer is 3,474.
Okay, so you get something like your 3.4 47, no? Then since it's like this, remember we have to go back again and check that, okay, when was this dude smoking? He started smoking at 7 o'clock. So they want to know at what exactly time will the percentage of nicotine be less than that 30% in his body. Remember, the 7 o'clock was our reference time. It now means we're going to be adding these 3 hours to that initial time that we had. It means we're going to be having that 7 plus 3, which is going to be at 10 o'clock. But we are not done. Remember, we have what? We have the 0.47. So the 0.47, you have to multiply it by your 60 minutes. This is going to give us what?
28 minutes.
Yeah, it means now you're going to get 28. So it means now you will see after your 1028, the quantity will be less than 30%. See, so after exactly 10, meaning you can be 1029, that's when the quantity in your body that's gonna drop below the 30% that they are referring to. So okay, let's just check. Okay, now they're saying what percentage of the nicotine remains after 12 hours. Okay, what percentage? We're gonna go about doing this one. Okay, let me check something. In the previous one, we did the K. Okay, let's try to write it down and see if we can get it correct. It's happening now. Okay. Okay, we have enough space. What's the formula? The formula is your Q is equals to your Q of 0 e to the exponent k of t. Then they're saying, okay, we have our Q of 0, then we have e. Our k is ln of 1 over 2, if I still remember, over 2. Then this multiplied by the 12. Then we have q into, what's the value for that one?
It's 0,0156. Hello? Oh.
It's
The answer is 0,0156.
It's a 0, I'm not hearing you properly. It's 0,056 or 156.
156.
156. Then you're just going to take this one and multiply it by 100. What percentage do you get? You're getting 1.56 now. So yeah, it means you're gonna go and check that. Okay, they're saying what percentage of the nicotine remains after 12 hours. Then you have your 1.56. Remember, you're going to go and do your conclusion that after the 12 hours you get your 1.56 percentage that remains in the plate. So now I think we've touched all the necessary and challenging questions in these themes. Then now we have to dive into the absolute values, your absolute graphs, and your whatever. I thought we would be done by 3 hours, but it has taken more and more than that. But on my side, I'm still enjoying doing math. We can just continue up until we're done in whatever time. And this one's are the second example. There are some nice examples that I've saved in the beginning. Okay, the properties, we've touched them in the examples. 3.4, I think I've seen it was somewhere here, if I'm not mistaken. This one, okay, let me remove it. And this one, did we do you? Okay, let me remove it. This one, we're still coming. The one that I'm looking for, that's this one. It's this one. Then we have unit 3.4, but we have another. What's this thing? There's an example that I'm seeing at the top. Where's that thing? Oh yeah, as I was saying, I was just checking for something. We have one more example this side. Then they're saying something, we've done something similar actually. They're saying what is the doubling time of an investment if an annual interest rate of 4.8% is compounded monthly. So let me just write it down this side, then you'll just finish it going down on your own, or just write it next to the question to be faster. So it now means you're going to be considering what you have. Your B would be equals to your B0, then you have your 1 plus your R over 12. This side you have your 12. You have your 12t. Then what are you going to have? You have your 2 BO is equals to your BO into your 1 plus your 4.8, it's your 0.048 over 12. Then you have what? You have your 12t. This one's cancels. Then you're left with your 2, which equals to yeah, you're gonna add this part. Then yeah, use the what's this thing? The linear to find the answer. Okay, let's just check. I don't have a calculator for this one. Okay, can someone just like quickly calculate what's the internal part? Okay.
So it's
How much?
1,004.
That's 1,004 to the exponent of 12 t. Then we have to that side. Then we have 12 t. We had something similar on this side, and like I confused it, and I said like we have to introduce e, whereas we can solve it using a ln, because remember we still can divide with a ln, because here, but we'll just quickly go and look at that example. We're gonna have ln of 2, that's equals to your ln of this, which is going to be 1.004 the exponent 12t. Then we have ln of 2 is equals to your 12t into your 1.004. Then okay, you can divide by your 12 ln of 1.004. Then your t would be equals to your ln of 2 divided by your 12 ln of 1.004. Then it gives you how much? Ln of 2 divided by 12 ln of let me close the windows.
The answer is 14,47.
14,47, which is correct.
Yeah.
The only problem about this thing is that like I have this other guide here. Sometimes it just shows the final answers there. There aren't any steps. But yeah, 14.67 is the answer that they're having this side. Having 14.67. Okay, on unit 3 we've touched everything. Let's just quickly check. Okay, these ones. Okay, just rub them out. Okay, yeah, let's just go back and rectify that mistake, because as I said, in my head I was having that concept of removing your ln by e. Which example was that? There was one example where we were trying to use the log. I'm not sure if you guys still remember that one, because actually in that example I now remember that we can divide our ln of something by ln of something like we've done on this one. But in my head I was just having that concept of properties. But like, should you see that example again? That's one example where they've given you a hint, like let use your q. Maybe yeah, you'll see it when you're busy. It's on one of these questions. When they say use your q is equals to q of 0.8 to the exponent t, we've actually used the other formula. But like, I think even if you use this one, you're supposed to arrive at the same answer. And the answer was somewhere like your 4.62. So if you're writing this one down, you will see it somewhere along your notes. You can highlight that one and use the proper formula, because in that one they were saying something like it's going to decrease by your 15%. Then you take your 1 divided by the 1 minus your 0.15, then you get your new a, which is going to be your 0.85. You use your 0.85 together with whatever information is going to be given, then you find your unknown. You find your unknown. Okay, so now we get to the absolute values. Then after the absolute values, we get to okay, this is 3.5, then 3.6. Okay, let me just check this side. Okay, it's this one. Okay, so with absolute values, I feel like they're kind of straightforward, but like, yeah, we'll just try to wrap up those quick. Let me just check also in the book if we're still on track with whatever that's supposed to be done, because I don't want us to miss anything. Even if we finish late, we should know that at least we've covered everything that they could potentially ask. Okay, so with the absolute values, I don't know, sometimes I find this chapter a bit tricky to teach, but like, yeah, it's just like I feel like for me it's just straightforward. So let's just assume or say you have something like here they've said you have an absolute value. So basically your absolute values are all about measuring your distance, and as you know, your distance can never be negative. Hence, where you get something like the absolute value of your 2, it basically changes that into your positive 2. Even if we have an absolute value of 2, will still be your 2. Then we have some examples that you see this side. We have an absolute value of 14 minus 2. This is the same as having your absolute value of 12. Then the answer will be 12. That will be for the first one. The second one, they have minus 3 minus 14. Why is that? That's minus 17. and we know the absolute value changes this into a positive value. This will be your 17. Then the one for, what's this one? We have minus 2 minus into minus 14. Then the one for minus 2, as we said, this is going to be positive. We're going to get 2 minus, then the one for the 14 is also going to be positive. So we're going to have 2 minus 14. We're going to have a final answer of minus 12. Then, okay, I think we've already finished those ones. Quick. Then we have those ones. Okay, this one they're saying they have x is equals to x minus 8 is equals to 0. This one you just solve it in the natural way. You have x minus 8 is equals to 0. Therefore you know your x is equals to 2. Which rule are we using? We are using property 2, as you can see this side. Then okay, we're done with that one. Then they have the second one. They say x is equals to 5. Then this one you can just say you have x is equals to your plus or minus 5. Which property are we using? We are using property 3. Then we have the next one. We have the one where they're saying your x is equals to your absolute value of x is equals to minus 5. So this one, it cannot be true, hence you will say no solution. No solution because of which rule? Because of rule property 1. Because of property 1, what more do we have? This one. Okay, this one we're going to consider it using property 3, because we're going to be considering two sides. This one, what do we have? We have x minus 8. What's happening then? Okay, we have x minus 8. We'll say it's equals to 2, or x minus 8 is equals to minus 2, according to which property? Property 3. So yeah, you also have to go sit, make sure that like you understand the properties, but I feel like the properties, they're just straightforward. Then from these two, it's the same. It's a situation where you have two cases. You're going to solve the values of your x. So the other one, you're going to get x is equals to 10. Then the other one, you're going to get x is equals to 6. Then as simple as that. As simple as that. Then now we get to these ones, which are the ones in example 3, where they say something like your sketch and stuff. Let me just get my adjuster for this thing. I want to write these things at an elevation at least. Maybe it's gonna be better. Better for me. Let me remove these books, this set. Okay, at least if I'm left with a few stuff this side, it's gonna be better. Let's put this one here. Then, yeah. Now we're going to be getting to the serious stuff. Okay. Let's see. What do we have? Then, yeah. We have an example 3, and above example 3, they've tried to show an example of some of the graphs that they were doing. Then remember this one, it's a graph for parabola. Hence you remember from the parent function x squared. anything about your absolute graphs, remember if okay, I'm gonna explain it on the other concept. Yeah, just like try to look at the difference between this one. This is a normal graph of parabola, but this it's an absolute graph for that one. You see exactly what happened in this region. This graph in this region where I'm highlighting in red, it was somewhere here, but when we're transferring it to the absolute value, it gets up until that side. You see? So this is the reason that when you take absolute value of a function, any negative values get reflected to be positive. You see, hence you see this as if it's reflected above the x-axis. So in a normal instance, it's going to be like this, but when you get to your absolute graph, it's going to be something like this. Because like I'm talking about this, because like I see that like same thing is going to be happening with this example that we have here. So let's just start with the first example, and we'll just like see it as we move. Then with your graphs solving graphically, the only parent function that you need to know in this unit is that you have your parent function, which is your absolute value of x, which will always be something like this. You see? You're going to get something like this. Then what else can you have? Then they might even ask you that, okay, let's just keep it that way. This is the parent function. Then the other ones that are going to ask you, these are the shifts. So if you get something, okay, let's just say you have an absolute value of x minus 1. It means now this is just going to be a shift along the x-axis, as I'm trying to highlight. So it means now you're going to go and try to solve the internal part that you have what? You have your x minus 1 is equals to 0, then your x is equals to 1, then you try to draw the new graph. But in your head, what do you keep? You always keep the parent function, the shape of the parent function. But now the vertex of your graph it's moved to unit 1. That's this side where you have your 1. It now means your new graph is going to be looking something like this. As simple as that. Then they can try and make this thing harder and harder. So the ones that like you see outside the, yeah, I'd say the bracket things, these are the values that you're going to be affecting only the y-axis. Let's just say here they said plus 1. So if they said plus 1, you know your 1 is going to be running somewhere along that side. If it was minus 1, it was going to be something that's going to go below the line. So yeah, like that. You'll just like get the hang of it as we're busy doing some of the questions, which I just think it's also straightforward. So what we have minus 2x plus 4. Then we have to sketch the graph. The other we sketch the graph, then the other we use the graph to solve these ones. But like these ones, yeah, I'll just like also teach you how you can use a number line. Do I still even remember how to? But like, yeah, we'll just like figure it out together, because like I think you can also solve them using a number line. Then okay, if you have something like this, first step, it will be to solve whatever that's on the internal side, which is basically your, what's this thing, your x-axis. Your x-axis, what do you have? You have your minus 2x plus your 4, that's equals to 0. Then you have your minus 2x, that's equals to minus 4. Then your x will be equals to 2. Then you're done with the first point of your vertex. Then now you go and try and check what would be the y-intercept. Then if you check for the y-intercept for that, it's not necessarily to actually check for the y-intercept, because like in most of the case they don't ask about it or interested about it. So yeah, where you see your x, you just like replace it with your 0. So you have your minus 2 into 0 plus your 4. Then what are you left with? You're left with an absolute value of 4. Then this is the same as having your 4. So now it means we can go and try and draw this one out. If we draw this one out, well, how is it going to look like? Remember, we have this and this. We have where it's gonna start the vertex. We have that to this side, then we have that for this side. You can just say it's going to be something that's looking like that. You see? So that's what I was saying. That one, it doesn't matter, but the 2, yeah, is the one that matters, because that's where you're going to be having that vertex. Some, they even just like interpret it or know by your slope, because like obviously you know you have your rise overrun here, which is your 1 over 1. You see? So let me just rub this one out. Okay, we're done with the first one, so we have to do which one? We have to do this one, which looks like that's a parabola. So the fact that you are able to look at this and say, okay, I have my minus x squared, you already know that it's going to be a shape that's looking like this. You see? But now the only difference is that like you have this 8 here, which is the y-intercept. So now it means it's going to be shifted up 8 units, and it's going to be something like this. So the only thing we have to check for is this x values that you see this side, 1, 2. But now remember what I said about the shape of your parabola graph when it gets to this point. I said the shape, it can be continuing downwards to the negative portions. So it means whatever shape that we're going to have a final shape that looks like this. It's going to be something like this. Then this, it's where it's gonna kink back and go like that. You see? So we're going to be having something similar like this one. You see? So as I said, the reason is that like the normal way it's supposed to be like this if it didn't have like those absolute brackets. But like I said, when you take an absolute value of any function, so any negative values get reflected to the positive sides or the positive portion, which is going to be this upper side. So let's quickly go and solve for that one. What do we have? Let me wrap this one. We say we have minus x squared plus 2x plus 8. Okay, I got that one. Let me just set up this. Okay, let's be quick about it. We have minus x squared plus 2x plus 8. This lesson is going to be hard to upload. It's already above 2 hours. Let me just stop this one and do it again.